Hi, I'm Kelly Gallagher, and I'm the chairperson of the Department of Chemistry and Biochemistry. We're here in the Physical Science Building, which is home to the Department of Chemistry and Biochemistry, the Department of Physics and Astronomy, and the Department of Anthropology. Today we're going to take you on a tour of our facilities, and you're going to get to meet some faculty and some students in our program, and you're going to get to learn about some of the cool things we do both inside and outside of your coursework, and some of the really great experiential learning opportunities that our students have here. So some of the footage that you're going to see today was taken pre-COVID, so you'll be seeing students working in the labs under more normal circumstances. And some of the footage was taken very recently, so you'll see how we've adapted to the pandemic. So we're going to go upstairs to the second floor now and take a tour of the department.
The chemistry faculty for me has been great. I couldn't ask for a team of staff to be any better for me. From being really personable in class, my small classes, to always having their doors open, that just makes me ready to learn and ready to be a student. My most recent research laid the framework for my future goals in a way that I didn't even think possible. What started out as a small project in green organic chemistry turned into something great for me because I was able to present it at the American Chemical Society National Meeting and Convention out in California. After being here for 4 years and being my final semester as a senior, I've definitely developed my goals as a student. I've developed my learning methods. Everything who I am now was not who I was when I came here, and it's for the better. I've grown a lot as a student and a person.
So here we are on the second floor, and this is where all of the department lab spaces, storage spaces, and offices are housed. On this side of the hallway are the teaching labs and research labs, and on the other side of the hallway are faculty offices. And one thing that is special about our department is that our faculty really enjoy and love working with students, and when we are in the building, 95% of the time our doors are open and students are welcome to come in and ask us for help or just talk about their goals or whatever is on their mind at the time. And again, we have a very accessible faculty, and we like to think of ourselves as more of a community than an academic department.
Hi folks, I'm Bill Vining. I'm one of the professors here in the Department of Chemistry and Biochemistry. And I'm going to tell you a little bit about our programs. So we offer two main majors. We offer a bachelor's degree in chemistry and also a bachelor's degree in biochemistry. And we're in one of the teaching labs we have here. This lab in particular is used for first year chemistry classes. And that's where you start out in terms of your program. You start out by taking what's called general chemistry. It's a 2-semester sequence. It's got 3 hours of lecture a week and 3-hour labs that happen here. And you'll come and you'll work here. Some experiments you'll do individually, some experiments you'll do as part of teams. And as you go through your career here, what you'll do is you'll build up to more and more sophisticated classes. So generally in your second year, you'll take courses in organic chemistry, and those have 3 hours of lecture again also, but then those have 4-hour lectures and 4-hour labs, and those are much more detailed and much more kind of involved laboratory experiments, which is why they need more time. And then in your second year, you start to diverge as to whether or not you're a chemistry major or a biochemistry major. If you're a chemistry major, you also start taking courses in inorganic chemistry. It's chemistry involving metals and things of that sort. If you're a biochemistry major, you start taking some more courses in biology to prepare you for your biochemistry career. In your junior year, then you actually start taking really quite sophisticated classes. You'll take things like analytical chemistry, which is a study of measurement, physical chemistry, which is the underpinning kind of theory for why things happen in chemistry the way they do, as well as biochemistry classes. And those classes then will get you to a level at which you'll be ready to start doing some really quite sophisticated research. And we'll be talking to you about the department's kind of emphasis on student research, which we find to be quite important and really, really useful for you once you graduate from Oneonta. So as you go through, what happens is you get more and more sophisticated classes, and each of those classes builds upon the other. So the kinds of things that you learn in one course are then used and assumed for the next course. And by the time you're a senior, you're really in a position to be an independent scientist for whatever you're going to do once you leave here. One of the things that we want to do is we want to give you an impression of kind of our philosophy of teaching, what we think is really important. So we're going to go to the lab next door here. And unlike the general chemistry, first year chemistry lab we saw before, this is actually the same, an identical lab, but it looks a lot different. And the reason is that we feel the most important thing about chemistry is that there are chemical reactions and there are chemical properties and we can actually see them. And what chemists do is they actually do experiments. And so experiments are the heart of what we do as scientists, and it's the heart of what we want you to experience as students. And so what we've been doing is we've been incorporating that into our distance learning activities this semester. And so we've converted this lab, instead of being a lab where experiments are done by students who can't do them this semester, what we're doing now is we're doing experiments as part of our teaching activities. And so as part of either our distance lab activities or even as part of our distance lecture activities, we're just doing experiments as we move along. So most of the things we do have experiments that we show students. So this is an experiment that we did earlier today where we're measuring the energy exchange that happens when a dissolution reaction happens. And so we were dissolving things, taking quantitative measurements and looking at the temperature change. This over here is an experiment we're doing where we are reacting copper and silver ions to make silver metals. So that kind of furry looking stuff is silver metal we made, and we're going to isolate that and measure it, and from that be able to talk about how many electrons are involved in that reaction. So the idea is we want you as students to not think of chemistry as something that's done on paper. It's something that's done in a lab. And so we are taking advantage of the fact that we have these facilities to be able to do this and incorporating it into our classes. And we will continue to do that even after COVID.
This is the organic chemistry lab, and again, this is the course that you will be taking in the lab that you'll be working in during your sophomore year. And organic chemistry is where you really learn how to build molecules. So what you'll notice is that in the organic chemistry lab, there's lots of cool looking and maybe somewhat complicated equipment. There's some equipment right here that Dr. Ron Bishop has been using this semester when he's been live streaming experiments for his organic chemistry labs in his course. So you'll notice as you look around this lab that it looks a little bit differently from some of the other labs in the building. And that's because it's been specially designed for organic synthesis. And that's a branch of chemistry where you're going to be using some dangerous solvents, some flammable chemicals. And so you'll notice that there are a lot of fume hoods in this room. While an important part of our curriculum is teaching students about green chemistry, which is the branch of chemistry that tries to make molecules in a more environmentally friendly manner, there is simply no way to make every chemical in an environmentally friendly way. So we have to have specialized spaces that have extra safety precautions for both the person working with the chemicals and for our environment. And so that's what you observe in this lab. So once you've made a molecule in the lab, it's important to be able to figure out what you've made. So one of the important parts of our curriculum is to teach you how to analyze chemical products. And that's an important skill for anyone who wants to work in industry. So right behind me is one of the first instruments that you will learn how to use. It's called a nuclear magnetic resonance spectrometer, or an NMR. And if any of you have had a sports injury or have had to have an MRI, the same technology is used in this instrument as is used in the MRI. It's just looking at molecules instead of your knee. So some of my colleagues will be showing you some of our other spaces where we have instrumentation that we teach students how to use and how students can access it.
Hi everyone, I'm Dr. Thomas Smith, Dr. Trudy Thomas Smith. Welcome to the chemistry department at SUNY Oneonta. I teach analytical chemistry here and general chemistry here. You'd see me in your first year maybe, and if not then probably in your junior or your senior year. So we are currently in one of the instrument rooms for our department. We have quite a few pieces of equipment in here, different instrumentation that you will use during the course of your curriculum. Most of it, again, would be when you're in your upper level courses. So when you come in and you do Gen Chem and you do organic, then you'll have enough experience with lab work to use some of the instrumentation in here. So what I'm going to do is give you a brief tour of the instrument room just so you can get a sense of what instrumentation is used in the department. And what I want to start with, though, is to just give you a sense that our program is certified by the American Chemical Society. And the American Chemical Society, what they do is they make suggestions as to content that should be covered in the curriculum. So we, of course, cover all of that content. We focus a lot on two of the main content areas in this room. One of them is spectroscopy. The other one is chromatography. Spectroscopy, just think about putting light on your sample and seeing what happens, determining what happens when the light is shown on your sample. So we'll start here with our photodiode array spectrophotometer. And what this does is you will have a liquid sample. You'll take your sample, you'll put it in we call it a cuvette. It's like a little glass container. And you'll put your sample into the instrument. You'll expose your sample to light, so a little cuvette like this, little glass container. Expose it to light, and then you'll get a reading of absorbance. You'll see this used a lot for pretty much all your molecules. So if you have an organic compound that looks transparent, that means it probably absorbs light in the UV region. You would be able to check that on here. You also use it for visible, so our nice pretty color transition metal compounds. You could show what the behavior of those compounds is like on this instrument as well. One of the chromatography instruments in the department is this one. So remember, spectroscopy is light. Chromatography, you're just talking separation. So if you have a mixture of completely different compounds in a sample and you want to separate them, you can separate them based on different principles. This one is going to separate your compounds basically as a result of their size. So smaller compounds versus larger compounds. And they get separated. You basically push some liquid through with your sample in it, and the compounds get separated along this column here. And then if you want to, one thing that's really cool with this instrument, let's say you have a compound you made and you want to purify it, and you want to separate out some of the things that are not, that are just not desired for your future project. Then you can actually separate the compound on the column and use the fraction collector here. So what will happen is you will get a certain amount of liquid in here that has just the compound that you're interested in it. So chromatography is pretty widely used, just different types of it, different types of compounds. And again, this is something heavily used in our upper level curriculum, especially biochemistry. So once you get to biochemistry, very, very likely you'll be actually using this instrument. This is an ICP OES, inductively coupled plasma optical emission spectroscopy. So the spectroscopy right back in the name again, so you know that in this case, some kind of radiation is involved. The biggest difference between the other spectroscopy instruments and this one is that the others will look at molecules and give you information and behavior about molecules. This one will give you information about elements by themselves. So this is really useful for things like environmental applications. Let's say you wanted to know what was in your water. You weren't sure if the lead content in your water was too high or something like that. You could check using this instrument. And what this one does is, instead of like a lamp with light, it uses a plasma. It uses an argon plasma, and the plasma will heat your sample up to really high temperatures so that you can get the breaking apart into the atomic and ionic states. And then it looks at the wavelength of the radiation that is emitted, hence emission, of those samples when they relax back down to the ground state. This instrument is also useful more and more in the biopharmaceutical field. They look at it a lot because what they do is they use it to figure out what's going into the media that they use to grow their cells. And if there are problems with cell growth, they can figure out if there is too high a concentration of one of the elements or something that's causing it. So that's a tour. We saw mostly spectroscopy instruments in here. We did see one separation instrument, separation as in chromatography. Our prized new acquisition, this is brand new, came to us in the summer, is a mass spectrometer. And if you guessed that that means we can separate compounds based on their mass, you would be correct. That's what this one is used for. This currently is being used a lot for research by our biochemistry professors. Our environmental people are using it too. There is a joint project between myself and a biology professor where a student is working at looking at the pheromones that are produced by a specific type of beetle. So that's a pretty interesting project. And here, in addition to being able to separate compounds based on their mass, what it does, it gives you a lot of information about the structure of a compound. So let's say you made something in the lab and you're not quite sure, like you've developed a brand new drug or something like that. You could put it on here and do two things. You could confirm, just based on the molecular weight, that the compound you think you made is the one you made. And you could also look at how the compound behaves when it is exposed to an electron beam. So what happens is it splits apart, and then you get, again, a graph. In this case, it's a mass spectrum where you have mass on the x-axis and intensity on the y-axis. We don't keep students away from instruments here at SUNY Oneonta. Students get a lot of hands-on experience. So far, there is no instrument that I've pointed out to you that students haven't actually used themselves, set up themselves, run their samples, and then analyze their data.
So now we're entering the lab that houses our biochemistry and analytical chemistry research. And students can get involved in research projects as early as second semester of their freshman year, because our student grant program has a shadowing program where you can work with a more senior student and learn techniques and skills so that by early in your sophomore year, you're prepared to take on your own research project. There's all sorts of different opportunities, from straight research projects where you're working with a professor on a question that they've defined, to a program that's rather unique in SUNY. We're one of 2 schools to have an iGem team, And you'll learn a little bit more about that from some of our students. But that program enables students to work in a team on a research project that they've defined themselves. And it's a great interdisciplinary opportunity for students to work together to do some good for the world.
Well, I was originally a chemistry adolescent education major when I first came in as a freshman. But once I started taking chemistry classes, I realized that I really wanted to be in the lab right after I graduated. I feel like I can always go back to teaching at some point, and I want to get that experience in the lab before teaching. I feel like it's very a substantial part of being a chemist is getting that experience, so that's really why I chose biochem. During my time here, for the past 2 summers, I've been staying on campus and researching with Dr. Gallagher and Dr. Feelhaber in a project called iGem. It stands for International Genetically Engineered Machine,
which is a competition that focuses on synthetic biology. So it's a way that many schools can develop synthetic organisms to help the environment, help others around them. And for us, we focus on a project that that would help our local community here in upstate New York. So we kind of develop a system that would detect the A2 allele in cows, because a lot of farmers are trying to enter the A2 milk because milk products are very hard to keep the price up, or there's a lot of middlemen. So we wanted to help them so that way they could breed their cows, because we want to build a detection system that tests the cows. So that way they could breed them and eventually enter the market of the A2 milk. Doing this project really made me realize that I can actually go out there and use my skills to help others.
It's pretty wonderful being able to work with my fellow peers in projects that we're equally passionate about. It really nails it home that science is a passion not only for me but for the people around me. And it's really awesome having an intellectual conversation about things that other people may not know when it comes to chemistry and biochemistry. Things that can be really hard when you're around people who also know at least a little bit of what you're talking about. It really helps. You know what they say, 2 brains work better than 1. So it's really awesome being around an awesome group of peers that have also been working on research with me. I think I wouldn't have been able to do research alone, and it's really helpful having a team, especially when we can all combine ideas together and figure things out.
Hi, I'm Dr. Ronald E. Bishop, or better known as Ron. I'm an assistant professor of chemistry and biochemistry here at SUNY Oneonta. Part of the reason I love science and chemistry in particular so much is because I'm a real hands-on kind of a scientist, and so the lab is my happy place. I'm okay in lecture, I love it there and love meeting the students, but this is the place I like to be. So where we actually are here is the Organic Research Laboratories. And this space, this room is shared by myself, by Dr. Jacqueline Bennett, and by Dr. Maurice Odago, and our research teams. Here at Oneonta, your major interface is going to be with a professor who is in his or her own right a highly qualified principal investigator. And so you get the fine points of how to think through an experimental design, how to report results that you've obtained, how to build a good resume, because we'll actually tell you what kinds of resumes we would be looking for if we wanted to hire you. And you get all of that directly from us, not second or third hand from other members of our teams. So that's a really big thing that we have to offer here at Oneonta. So whether you're interested in working in fully biochemistry or in the interface between organic and biochemistry, or the interface between organic and inorganic chemistry, any of these multidisciplinary kinds of things, you can get yourself involved in research in our chemistry and biochemistry department. And some of the benefits that you will find is, first of all, you learn lab techniques that we don't have the chance or the time to teach you in pretty large labs filled with students. We can teach you the fine points, which are essentially the difference between results and no results, or reproducible results and results that nobody can ever make sense of. But the other thing is that most of our studies are real world kinds of things. Dr. Thomas Smith is our analytical chemist, and she's very involved with things like water chemistry, particularly things like water pollutants. And all of our projects are multi and cross-disciplinary. And this is the sort of thing you won't get in a single class, which is always, by the nature of how classes are run, focused on a single set of topics. It's organic, or it's analytical, or it's inorganic. In research, you've never worked on a project that has ever read your resume. And the things that you're trying to do are things that are being attempted for the first time in the world, and there's no expert out there who can tell you what you should expect. This is a very exciting and creative place to be. It's also a very cross-discipline and multidisciplinary place to be. We work on real-world problems, and that's part of what makes it challenging, and also part of what makes it really fun.
So that's it for our tour of the chemistry and biochemistry department and programs. We hope you found it informational, and we look forward to seeing you on campus soon.